Hello everyone. Today we're going to look at structural formula. Now structural formula are basically a drawing of the molecule. It shows the shape of the molecule. Of course, drawing on flat paper doesn't give the three-dimensional representation very well, but it's better than just writing a few symbols on the page. So let's have a look. Structural formula. The structural formula show the shape of molecules. Molecules are combinations of nonmetals like carbon, nitrogen, oxygen and hydrogen. Carbon normally has 4 bonds, nitrogen usually has 3 bonds, oxygen usually has 2 bonds, and hydrogen normally has 1 bond. Let's look at how this might work out in practice. Let's draw the structural formula of water. Now you might think that's pretty straightforward, but let's give it a shot. We've got 1 oxygen, and we've got 2 hydrogens. Okay, how can we draw the molecule in such a way that oxygen gets 2 bonds and each of the hydrogen gets 1 bond? Well, how about like that? There we go. Now the oxygen has 2 and each of the hydrogens has 1. Let's try methane. Carbon is there. We've got 4 hydrogens. We might try just putting them round about to see how that works out. Okay, now the carbon has to have 4 bonds and each hydrogen has to have 1. So let's just join them up like this. Oh, and there we have it. That's the structural formula of methane. Carbon has 4 bonds and each hydrogen atom has 1 bond. Ammonia, NH3. Well, each hydrogen can only have 1, so they can't join to anything else except maybe to the nitrogen, because if they join to each other we'll have a problem. Okay. Whoops, I've drawn a C. I mean an N. There we go. There's the N, and we can join it up. Actually, I might just fix that. Nitrogen can join onto a hydrogen. It can join onto another hydrogen. It can join onto another hydrogen. And that's it. Nitrogen has 3 bonds. Hydrogen has 1 bond each. So that makes the structural formula for ammonia. Alright, let's try some other ones. Here we've got acetic acid. Okay, so we've got a part of the molecule here which is CH3. Let's draw that part first. We've got C and 3 hydrogens. Now where could they go? Maybe we could put 1 there, 1 there and 1 there. See how the carbon gets to have several bonds and the hydrogens, they only get 1 each. Then we need to join that onto the rest of the molecule. In the list up the top here, the parts of the molecule, we've got another carbon, so I write that down. Then we've got an oxygen and another oxygen and a hydrogen. Now we have to put them in such a way that the carbon actually ends up getting a total of 4 bonds. It's already got 1 over here, okay? It's already got 1. It's going to get 3 more. That would make 2 more, and the oxygen there is satisfied because it has got 2 bonds, and that leaves 1 more from the carbon. What about if we did this? There we go. That's acetic acid. Job done. Sometimes when you see the atoms in the molecular formula, okay, so this is a molecular formula. It's actually a semi-structural formula, but that's okay. Semi-structural because you can almost see the structure coming out in the form of that molecule, in the form of that how that's written. If we were to write H, C, C, H, well, we'd nearly be there. We've got all the elements, we've got the right number of elements, but the carbons don't have 4 bonds. Okay, we've got a problem. The carbons don't have 4 bonds yet. We could actually increase the number of bonds here between the carbons. Okay, and now we've actually got 4 for each carbon. Hydrogen, carbon, 1, 2, 3, carbon, hydrogen. Look at this carbon here. I'll change the colour. Okay, look at this carbon here. It's got 4 bonds. Okay, it's got 1 bond here and it's got 3 bonds here. So that means it's got 4 altogether, and that's what we want. And this carbon too, it also has got 4 bonds. There's 3 on this side, on the left hand side, and there's 1 on the right hand side. That makes 4. So we've done the right thing. We've got that one. Let's look at propane now. Let's get my pen working properly. Propane is C with 3 hydrogens. Okay, so the carbon now, the first carbon, has got 3 bonds to it. It needs to join up to the next thing. The next thing is a carbon, which maybe has got 2 hydrogens stuck onto it, the way that formula suggests that. So put H there and an H there. And then we've got this last part of the molecule. Maybe that's a C like that. Where can we join the hydrogens on? Well, maybe just straight on the end there, like that. And there we have it. That's the molecular formula for propane. When we draw the semi-structural formulas like this, okay, the semi-structural formula actually nearly suggests what the molecular formula is. So I'm giving you a little bit of a hand there. If I had written the formula for propane C3H8, okay, maybe it would have been a bit more difficult, but I've sort of written it out for you. So I want to give you a hand there, and let's see how you go. Now these ones here are the ones I want you to do. There's 10 of them. They might be a bit tricky. They might be not so tricky. Give it a shot. Some of them are kind of interesting. Give it a try. Email me your answers. Email me if you've got any questions, and let me know how you go. Bye.